Okay, so the SI system is the International System of Units. It's the modern metric system, and there are a few rules or conventions that we tend to use, and I'm going to go over what those are. So unit symbols are always lowercase letters unless the unit is named after a person. The one exception would be when you guys use the unit liters, you should always use a capital L. It will be deemed inappropriate to use a lowercase l. Okay, and then full names of units are always written in lowercase. The only exception would be degrees Celsius. Unit symbols should never be pluralized. And then for symbols, they're only going to be followed by a period at the end of a sentence. In general, the term mass replaces the term weight, and then CC should not be used in place of mils or cubic centimeters. That would be considered incorrect. And then if you've got a value that's less than 1, put a 0 in front of the decimal point. So 0.54 would be deemed appropriate, as opposed to 0.54 would be deemed inappropriate. Okay, and then a space rather than a comma separates digits of 3 units, or separates sets of 3 digits. Let me give you an example. I don't do this, but your book does this. So if we're looking at 500,000, you'll see 500 space 1,000 and then maybe like grams. Okay. Decimal fractions are used over common fractions. So 0.25 is considered appropriate. 1/4 is considered inappropriate. Marco, am I interrupting something? Are you good? Okay, abbreviations like SEC, CC, or MPS are avoided. So S is the abbreviation for second. That's given here in this table, for instance. Centimeters cubed would be cm to the third, and then meters per second would be m/s. And then anytime you guys are writing a number with a unit, like let's say you're writing up a lab report, there's going to be a space between the number value and the unit symbol. So technically 4.6 with a space and then grams would be deemed appropriate. Okay. Use the appropriate symbols rather than words when they come after numbers. So like 5.0 grams per mole. So G/mol. We'll talk about the mole later. It's a quantity of things in chemistry. And then 5.0 grams/mole. This would be deemed inappropriate. And then the last one, a specific temperature and a temperature change both have units of degrees. Make sure you guys put the degree symbol in front of the C or the F. The degree symbol doesn't go after it, okay? So on the top of the next page, I know I just threw a lot at you, but at the top of the next page, there's a quick check where you're going to be applying these things, and that's what I want you to do. Let's see what you guys come up with. Okay, for number 1, did you change the kilos to kilograms? And that was the only change that you made. And then for number 2, you shouldn't have this fraction here. It should be 0.5, and then there isn't a period between the C and the M, and then this should just be CM. Right? Okay, and then for number 3, you want to replace the word weight with mass. And then this actually is megaliters because this is a capital M, and then liters has to be a capital L. So this would be milliliter, lowercase m, capital L. And then can't pluralize grams. This would just be a G for grams. And then the Celsius here is a lowercase. This should be a capital C, like that. Okay. And then for number 4, liters shouldn't be spelled out. This should just be a capital L. And then the CCs we can't use, but we could use centimeters cubed. And then for number 5, you should have a 0 in front of the 0.9, and then the degree symbol should be in front of the Celsius. And that was it. Good enough? Okay, let's talk about accuracy and precision. So let's come down here to the bottom part. So here we've got a number of different measuring devices that have different precisions. So let me explain a couple of them. So when you've got a ruler like this right here versus a caliper, which is this. Okay, the caliper is going to be more precise than a ruler. So what that means is you can record lengths further places beyond the decimal. So you can go further to the right in your lengths than you could with a traditional ruler, okay? Then we've got a burette versus a pipette. So this right here is the burette. This right here is the pipette, okay? So these two devices are typically used to deliver specific volumes, and they usually allow us to record 2 places past the decimal. These are generally going to be more precise than a graduated cylinder would be, okay? You can also relate this to the opening. So the opening size, as you can see, this opening size in the graduated cylinder is relatively large in comparison to the opening on the burette and the pipette, okay? So that also contributes to the precision of the measuring device, okay? Now, anytime you guys are using something to make a measurement in the lab, we will never be able to use a measuring device that gives us an exact measurement. That's because every measurement that you guys make in the lab will have some sort of uncertainty associated with them. Technically, there is only one exact measurement or something that has no uncertainty in the world, and that is in France. Can I move this page? Yeah? Okay, so there is a helium-filled bell jar with 1 kilogram of a mass in it. Let me turn this page. Here it is right here. This is the only exact mass in the world, and everything is measured in comparison to it, okay? Now, when we talk about precision, we are talking about 2 different things. We're talking about the number of places beyond the decimal that you can record a measurement. So that would be this right here. So the exactness of a measurement is the way that your textbook likes to refer to it. And this simply means more decimal places. God bless you. The other definition for precision has to do with, can you reproduce the measurements one after the other? So if you're measuring, let's say, a piece of metal, you're getting the mass and the volume and you're measuring its density. The question is, can you reproduce all those measurements repeatedly? And if you can, then your measurements would be precise, okay? Now, the other thing is accuracy, which is actually measuring how close you are to the true value. And you might be above the true value or below the true value, and that is interpreted to be something else, which I'll talk about in a little bit. But for now, let's take a look at the quick check. So let's come down here. And the first question they ask is, which of these is likely the most precise? Well, which one has the smallest opening? Yeah, the syringe. Okay. And then which is likely the least precise? Which one has the largest opening from what you can tell? Exactly. Is the most precise device necessarily the most accurate? No, not necessarily. Okay. All right, let's go on to types of errors. Okay. At the bottom of the page, they talk about systematic error and random error. So systematic error means that you're going to show error in the same direction. So that means you may be above the true value for all of your measurements, or you may be below it. And if you are equally in high and low directions, this is known as random error. Okay, so let's turn the page. Okay, so let's address precision and accuracy using this quick check. So here, if you take a look, let's go ahead and label these numbers 1, 2, 3, and 4. Okay? And let's comment on how precise the measurements are in each of the groups. So if you take a look at groups 1 and 3, for instance, precise measurements, you want them to be close together. Are they close together in 1 and 3? No. So I would say 1 and 3 would be low precision. Which two do you think are higher precision? I mean, they're relatively closer together.
2 and 2.
Yeah, 2 and 4. Okay, for number 2, what about the accuracy? Accuracy is going to be how close you are to the true value. And you can see here they have indicated the true value is at the center. Okay, so which ones do you think have high accuracy?
3 and 4.
Yeah. And that means 1 and 2 would have low accuracy. And then let's talk about systematic error versus random error, okay? So on the previous page, it says that systematic error is when you have errors in the same direction. Which two groups seem to have errors in the same direction?
1 and 2.
Yeah. So that means random errors would be in all directions, so that would be which groups?
3 and 4.
Yeah. Okay, let's move on. Let's take a look at uncertainty. So like I said before, every single measurement that you make has some degree of uncertainty in it. And the question is, how do we determine where we're going to record measurements to? In this class, I will not be using range uncertainty, which is where they make a measurement and they put a plus or minus after that. I left that in the book because sometimes you might see that in other classes. But what I'm going to do is I'm going to talk about making measurements using graduated cylinders, okay? So anytime you're making a measurement using a graduated cylinder or anything with divisions, you have to determine the division size. So if this is 50 and this is 60, and we're going to say that our units are milliliters, every division is going up by 1 milliliter. Would you agree with me? So that means your division size is 1 milliliter. After you record the division size, or the increment size, which is the same thing, this tells you that you are certain up to that decimal place. So that means we are certain to the ones place. And when you go to record the volume that is in this graduated cylinder, you have to go one place beyond that to give me an estimated digit, okay? So the actual volume here, if you look at the bottom of the meniscus, this would be 55. We are between 56 and 57, agreed? So 56.5, it looks like it's halfway between, right? So 56.5 milliliters would be the appropriate volume. We are certain up to the ones place, right? Okay, this digit right here is my estimated digit that I provided. They will sometimes refer to this as the uncertain digit. I had to add that digit in order to reflect the precision of the measuring device. If I hadn't done that, my volume would be deemed incorrect. Does that make sense? Okay. Is this something that you guys have done before?
Yes.
Yes. Who is not? Okay. So let me stop this for a second.